Have you ever wondered why the moon looks roughly the same size as the sun, despite the sun being vastly larger? It all boils down to an intriguing concept in geometry known as the solid angle. Imagine standing under a vast dome, like the sky itself. When you look up at the stars, each star occupies a certain part of that dome. This portion is what mathematicians call a solid angle. It is a measure of how large an object appears to an observer, not how large it actually is. The solid angle is expressed in a unit called a steradian. 1 steradian is the solid angle that, when viewed from the center of a sphere, cuts out an area of the sphere's surface equal to the square of the sphere's radius. Consider a simple analogy. If you were to project a flashlight onto a wall, the light spread on the wall represents a solid angle. The closer you are to the wall, the smaller the spread. The further away, the larger it appears. This analogy simplifies the concept without diving into the complexities of the formula, which states that the solid angle, in steradians, is the area on the sphere divided by the square of the radius of that sphere. Solid angles are also measured in other units like square degrees or square arc minutes, but steradians give a direct link to the geometry of spheres, which is pivotal in fields such as astronomy and physics. For example, the solid angle of a cube face, when viewed right at its center, is exactly 1 steradian. This is because the area it projects onto the unit sphere around it matches the square of the sphere's radius. Similarly, a complete sphere around an observer subtends a solid angle of 4 pi steradians, enveloping the observer in every direction. These concepts are not just mathematical curiosities, they have practical applications in fields like astrophysics, where understanding the solid angles subtended by celestial bodies helps scientists quantify the light or radiation that reaches us from them. For instance, despite their vast differences in size and distance from Earth, the Moon and the Sun subtend similar solid angles, making them appear almost the same size in our sky. In summary, solid angles help us grasp how large objects appear based on their distance and position relative to an observer. This understanding is crucial across various scientific disciplines, providing insights into the fundamental ways we perceive the world around us. So next time you gaze up at the night sky, remember, you're looking through a window defined by solid angles.